For the last decade, we have built programmable money on imperative blockchains, networks where the user must define the exact sequence of steps to execute a trade. Think of these systems as a single, massive toll booth. Every piece of global traffic is forced through one narrow gate. This imperative architecture creates an inherent bottleneck. If you buy a coffee at a local cafe, your transaction waits in the exact same line as a multi-million-dollar international bank transfer. When demand spikes, the results are immediate. The network clogs, execution slows down, and the cost to process a simple action increases sharply. Engineers have tried to patch this by building secondary networks, or layer 2s, on top of the main chain. But routing traffic through temporary side roads doesn't eliminate the single toll booth waiting at the end of the highway. A single-state architecture is not built to scale for the economic activity of the entire globe. The structural limits of the design eventually cause the system to stall. Congestion is only half the problem. The second flaw is that this single waiting line is made of glass. Every pending trade is entirely visible to the public. This timeline diagram illustrates MEV, or maximal extractable value. MEV is the profit that automated bots pull from regular users by analyzing the public queue and manipulating the order of trades. Automated algorithms, known as searchers, scan the line for targets. When they spot one, they pay a premium to jump ahead, executing their own trades fractions of a second before the user and siphoning off the value. In this setup, the user has no structural defense. The network's design requires them to broadcast their financial data to anyone watching. The result is a highly adversarial environment, a dark forest where everyday participants are vulnerable to systematic exploitation. To solve this, the Anoma protocol moves away from the single-chain model. Instead, it operates as a distributed operating system. This topological map shows the core scaling mechanism, fractal instances. These independent network environments process specific data without checking a global ledger. Like a cellular network, a local tower handles neighborhood calls, only connecting to the global grid to cross state lines. This means a specific online community, an autonomous game, or even the Swiss central bank can spin up their own independent fractal instance tailored to their exact security needs. Because these instances are isolated, they process their own localized tasks quickly. They do not have to share block space or compete for bandwidth with the rest of the world. Yet, they remain interoperable. When a local user needs to interact with an outside asset, the instance connects back to the broader Anoma ecosystem to settle the trade. By physically distributing the computational load across fractal instances, Anoma removes the constraints of a single chain bottleneck, allowing capacity to grow as more instances are added to the network. This addresses the physical speed limit. But to protect the data flowing through these localized networks, we have to change how users actually communicate with the system. Anoma shifts the primary unit of interaction from a transaction to an intent. A transaction dictates the mechanical execution, the exact path required to complete a trade. An intent simply declares the final desired outcome, like I want to trade asset A for asset B, without specifying how to get there. By only broadcasting the desired outcome, the user no longer has to map out complex routing logic. They outsource that work to the network's automated solvers. Decoupling what a user wants from the mechanical execution required to achieve it is the first step in neutralizing the network's predators. Anoma applies programmable privacy before an intent reaches the public gossip layer. It encases the request using multi-party computation, splitting sensitive data so no single participant reads the whole message. This encrypted data is routed to solvers, specialized entities competing for the most efficient route. This triggers a blind auction. Solvers must commit to a price and an execution path without knowing the specific tokens or amounts hidden inside the user's intent. This structural pre-execution privacy breaks the MEV business model. An algorithmic bot cannot front-run a target it cannot see. The blind auction forces solvers to compete strictly on providing the best execution for the user, rather than exploiting an information advantage. Anoma integrates these two components, the expanded capacity of fractal scaling and the security of shielded intents. A user can seamlessly move across different security domains, interacting with local community currencies and global institutional assets through a single interface. Throughout the process, their data remains sovereign. Trades settle through optimized routes, and extractive third-party taxes are structurally minimized. Anoma is not simply a faster blockchain, but a structural shift in how the internet coordinates value, moving away from extractive models towards infrastructure that prioritizes the user.